Hello everyone and welcome to the first episode of the Metroidvania tutorial series, where we'll be teaching you how you can create a Metroidvania like Hollow Knight in Unity 2D. Our goal for this series is to help you recreate the movement mechanics, the melee mechanics, and the spellcasting mechanics of Hollow Knight. In this inaugural episode, we'll be covering how you can create a new Unity 2D project, how you can create the basic walk and jump movements of our player character, how you can animate these movements, and how you can get the camera to follow the player. By the end of today's episode, you should have a character that walks, jumps, has a variable jump height, and has a camera that follows the player around. First off, let's create a Unity 2D project. What you want to do first is click the New Project button at the top right hand corner of your Unity hub. Then select 2D Core, which is the Unity template we'll be using for this tutorial. The Unity version I'm using is 2021.3.0 F1, and you may use other versions if you want to. However, there are some features that I'll be using that may not exist in your Unity version, so it's recommended that you choose the version that I'm using right now. Next, we want to rename our project because having a project called my project isn't the best. So I'll call mine Metroidvania Prototype. Once you've renamed your project, we can create our project. Once the project has been created, go to your Hierarchy tab, press the plus sign, press 2D Object, Sprites, and then Square. Now as you can see, a square has been added to our scene. Let's name this square Floor. So this will be the floor that our player will be walking and jumping on. Let's reset its position. Now, we'll create another square called Player. So this will be our player character that will be moving. And to both of these game objects, so the floor and the player, let's add a box collider 2D. This box collider component will allow our two game objects to collide with each other. Now on the floor, let's expand its X scale to 1000, so that when the player has to walk and jump on the floor, it will have space to do so. Now on the player character, let's add a rigid body 2D component. Rigid body 2D. This will allow the player to interact with Unity's physics system, and basically this component gives the player weight. So if we click on play, we should see the player fall onto the floor. And there we have it. Now let's start creating the player walk. Now what we want to do is we want to add a script called player controller to our player, so that this script will be able to control the game object and allow us to move. Now how we add a script is by pressing add component, then typing in the name of the script you want created, so ours will be called player controller, and then pressing new script. Then create an add. Now once this script has been created, let's let it load. Once this script has been created, it will be attached to the player game object. Now let's open this script and start writing some code.
Now that you're in the player controller script, let's get the player walking. First, create a private rigid body 2D variable called RB. Next, in the start function, we'll set RB to the player's rigid body 2D component. Next, we'll create a variable called walk speed, which will determine the player's speed while walking. Finally, let's create another private float variable called x-axis. This float variable will be used to help us get the directional input from our player. Next, we'll create a function called getInputs and set our x-axis float in the function to input.getAxisRaw, and we'll get the horizontal axis. You can change these buttons in the project settings of your game, but for this tutorial, the default bindings are good enough. Finally, we'll add getInputs to the update function so that the x-axis variable is updated every frame. Next, we'll create a function called move and add the line rb.velocity equals new vector 2, walk speed multiplied by x-axis rb.velocity.y. This sets our player's horizontal speed to our walk speed multiplied by the directional input, while our player's vertical speed remains unchanged. Add this move function to the update function. Now, we return to our Unity project and click play. And we'll see that our player square can now move around. His movements right now are quite slow, so we'll want to increase the value of walk speed. However, jumping back and forth between the script and the Unity editor is a tedious process. So what we want to do is to make the walk speed editable in our inspector window by adding serialized field to our private variable. You can also make the walk speed variable public to edit it in the inspector window. However, since we're only using walk speed variable in the player controller script, it would be much cleaner to simply make the walk speed serializable rather than making it accessible to all other scripts. Let's also clean up our variables by adding a header at the top, which helps us organize our inspector window. Now, in the inspector window, let's increase the player's walk speed to about 20. Let's also increase the gravity scale, which will increase gravity to about 9.5 so the player falls faster. And that's our walking mechanic done. Next, we'll give the player the ability to jump. Go back to the player controller script and add a private float called jump force, and then set its default value to 45. I would like to add that I encourage you to change any of the values that I've used in the video to fit the needs of your particular game. In my opinion, the best way to learn from a tutorial is to do what it teaches and then recontextualize its mechanics to fit your needs. Now, when making a jump for the player, we need to make sure that the player is only jumping when it's on the ground. If we allow it to jump while it's in the air, the player will be able to fly upwards indefinitely and essentially start flying.
I'm escaping to the one place that hasn't been corrupted by capitalism. Space!
So, to detect the ground, we'll be shooting a raycast from the bottom of the player and checking whether the raycast hits a game object that's on the ground layer. First, we'll go to our floor game object and go to its layer drop-down menu. Let's add a layer, then name this new layer ground. Then set the floor's layer to ground. Then we'll add a child empty game object to the player called ground checkpoint. This ground checkpoint will be the point at which the raycast casts from. Let's also set our ground checkpoint to the bottom of the player, so that later when we raycast, we can set the raycast origin to the bottom of the player. Once you've done this, go back to your script and create a serializable transform variable called ground checkpoint, and set it in our Unity editor. Let's also create a serializable private float variable called groundcheck_y, which will be the distance our ray travels. Let's set its default value to 0.2. Then we'll add another serializable layer mask variable called whatisGround, and set it in the Unity editor to our ground layer. Finally, let's organize our variables by adding a header called groundCheckSettings. Once we're done organizing our variables, let's add a public bool function in our player controller script called grounded. In grounded, we'll add a physics2d.raycast. Then we set the origin of the raycast, the direction of the raycast, how far the ray will travel, and what layer the raycast is trying to detect. Then we'll return true if the raycast hits a game object on the ground layer. We also want to raycast from the edge of the player, as we want grounded to return true even when the player is standing near an edge. So what we'll do is create a serializable private float called groundCheckX and set its default value to 0.5. Then we'll add to our if statement two more raycasts that add and subtract to the x value of the ground check position. We'll separate them with an OR operator so that if even one of these raycasts return true, grounded will return true. Finally, we'll add an else statement to return grounded as false if none of the raycasts hit a ground layer game object. Now that we can detect if the player is on the ground, we can get the player to jump. First, create a function called jump and add it to the update function. Next, we'll add if input.getButtonDown and grounded, rb.velocity equals new vector2, rb.velocity.x, jump force. This sets our vertical speed to the jump force variable value when the jump button is pressed and the player is on the ground, sending the player upwards. The default jump button is the space bar. Once again, you can change this in the project settings for Unity. Now, if we play our game, the player should be able to jump. Let's add another platform to test out our jump mechanic. If we play the game, we can see that our player, when it hits the platform, rotates around. Since we don't want this, what we want to do is we want to go to our player's rigid body component and go to the constraints and freeze rotation. Next, we'll add if input.getButtonUp jump and rb.velocity.y is more than 0, then rb.velocity equals new vector2 rb.velocity.x, 0. This allows the player to cancel their jump when they release the jump button while the player character is jumping upwards. This allows the player more freedom in their movement when they are able to control their jump height. This mechanic is known as the variable jump height. And now if you test the game, you should see that we now have the ability to stop our player's upward momentum by releasing the jump button. If you notice, however, when the player hits the side of the platform, the player sticks to it. This is because the player's friction value is too high. To change this, we'll create a physics material 2D in our assets folder by right-clicking and selecting create, then 2D, then physics material 2D. Let's call this new material player physics material. And then let's set its friction value to 0. Let's then set this new physics material in the player's rigid body component. Now, if you playtest the game, the player will no longer stick to the sides of the wall. Next, let's start animating our player character. The assets I'm using are from the Night Sprite asset pack, and the link to its Unity asset store page is in the description below. First, we want to configure our sprite settings so that our sprites don't appear blurry and compressed. What we want to do is set its wrap mode to clamp, its filter mode to point to no filter, and its compression mode to none. After configuring all of our sprite settings, let's change the player sprite to one of the idle sprites of our knight. Then, let's adjust the box collider and ground checkpoint accordingly to match the new sprite. Once this is done, we'll open up our animation window and select our player game object. Then, let's click create on our animation window to create a new animation clip. We'll be creating the idle animation first, so let's call this animation clip player_idle. Then, we'll drag the idle keyframe sprite into the animation timeline and adjust the keyframes to change our animation to something we like. Next, we'll create the player walk and player jump animations in the same way. Now if you press play, you'll notice that only the idle animation plays. This is because we haven't added any transitions between our animations yet. To do this, select your player, then go to its animator component, which was automatically added when you created your first clip, and open the player's animator controller, which was also created for you when you created your first clip. This will open the animator tab, where you'll see all of our animations in animation states. Now you see why only the idle animation plays, because it's the default animation and the only one that's connected to start. Now let's add two-way connections between all of our animation states. Next, we'll disable has exit time and set transition duration to 0 for every transition between our animation states. We want to do this because we want these animation transitions to happen instantly and without delay. Once that's done, we need a way to tell the animator controller to transition between these states. To do that, we need to set the conditions for when these transitions should happen. First, we need to create parameters on which the conditions will be based. We'll create two bool parameters, one called walking and the other called jumping. Remember to keep in mind how you spell these parameters, as it will be important later. Now let's go back to our player controller script, and let's create an animator variable called anim. Let's set this in the start function to the player's animator component, just like how you created a reference for the rigid body 2D component earlier in the video. Next, in our move function, we'll type anim.setBool walking rb.velocity.x is not 0 and grounded. This sets the walking parameter to true only when the player is on the ground and moving horizontally. Otherwise, the bool will be set to false. We should also set our jump animation loop time to false, as we don't want our jump animation to loop. Next, in our jump function, we'll type anim.setBool jumping is not grounded. This makes it so that our jump animation plays anytime the player isn't grounded. Remember to check that the spelling of your parameters in setBool and the animator tab are the exact same. Finally, we'll set our conditions for the transitions. If walking is true, we'll transition from idle to walking, and from walking back to idle if the walking bool is false. Then, for both transitions to the jumping animation, we'll want to set the conditions to if jumping is true. And vice versa, for both transitions out of the jumping animation, we'll want to set the condition to if jumping is false. Now, when we playtest our game, our player should be fully animated. And now we should be fully done with our player animations, right? Well, yes, but actually no. To put a stop to our player's moonwalking chicanery, we'll need to get our player to face the direction he's moving in. To do this, let's go back to our player controller script and add a flip function. In this flip function, let's add if x-axis is less than 0, then transform.localscale equals new vector 2, -1, and transform.localscale.y. Else, if x-axis is more than 0, then transform.localscale equals new vector 2, 1, and transform.localscale.y. So what this does is if the player is pressing the left button, it sets the player character's x scale to -1, so that the player character will flip to face the left. And vice versa, if the player presses the right button, then his x scale will be set to 1 and he'll flip to face the right. And now if we test out our flip function, we should see that the player flips to face the direction he's moving in. Finally, let's get the camera to follow the player. Let's go to the main camera and create a camera follow script. Next, go to our player script and let's create a singleton of our player controller so that we can reference the player script from other scripts, as well as making sure that any duplicate players will be destroyed. How it works is that we'll first create a public static player controller variable called instance. Since this instance variable is public and static, it will be accessible by all other scripts. In the awake function, which calls before the start function, if the instance variable has already been set and this player controller is not the one set as instance, then we destroy this game object. Else, we'll set the instance variable to this player controller instance, since this would mean that the instance variable hasn't been set yet. Now let's go back to the camera follow script and let's create a serializable private float variable called follow speed with a default value of 0.1. This will act as the speed at which the camera moves towards the player. Now in the update function, let's add transform.position equals vector3.lerp transform.position playercontroller.instance.transform.position and then follow speed. This line of code will move the camera's position towards the player's position at the speed set by follow speed. However, if we playtest this, you'll notice that the camera can't see the player. This is because the camera has moved right on top of the player and the player is not in its field of view anymore. To counteract this, we want to move the camera back to move the player back into its field of view. To do this, we'll create a serializable private vector3 variable called offset, and we'll add this offset to the player's position. Next, we'll set the offset in our inspector. To move the camera back, we'll simply set the z value of our offset variable to -10. You may also, if you wish, add the x and y values of your offset to position your camera as you desire. Now, if we playtest the game, we should have a walking, jumping, and animated player with a camera that follows him around. And that's all I have for you in this episode. In the next episode, I'll be further expanding our player's movement repertoire by adding the dash ability, the double jump ability, and giving our player jump buffer and coyote time. Thank you for watching till the end, and I hope you've enjoyed the video. Hey there! Want to support what we do? You can help us by becoming a patron. This will give you access to the project files for our tutorials as well as patron exclusive posts on our blog. Any support you give will be invaluable to us, as currently we're only making back about 20 cents for every dollar we put into content creation. Your patronage will go a long way to help us make this a sustainable endeavor. See you in the next video!